something just past our sun, and it's unlike anything we've ever seen. It didn't just reflect sunlight. It glowed brighter than physics allows. It didn't just move through space. It accelerated against gravity itself. They're calling it 3I Atlas, an interstellar traveller that behaves like no comet, no asteroid, and maybe no natural object at all. Don't blink, because what NASA's satellites just captured near the sun might be proof we're not alone. Stay with us. This is the story of 3I Atlas, the interstellar mystery. Our story begins in the cold, quiet darkness of space. It is a story about a visitor, a traveller from a place so far away our minds can barely imagine the distance. This is the story of an object named 3I Atlas. It came to our solar system from a different star. It is what scientists call an interstellar object. The word interstellar simply means between the stars. Our sun is a star. Our solar system is like our home, our neighbourhood. But there are billions of other stars in our galaxy, billions of other neighbourhoods. This object, 3I Atlas, is not from our neighbourhood. It came from one of those other distant places. Imagine a strange seashell washing up on a beach, a seashell that is a different shape and colour from any local shell. You would know instantly that it came from a faraway ocean. 3I Atlas is like that seashell. It is a piece of another star system, delivered to our doorstep. The discovery of such an object is always a moment of great excitement for scientists. Our own solar system has a limited number of building blocks. We have our planets, our asteroids, our comets. We have studied them for centuries, but they are all made from the same stuff, from the same cloud of gas and dust that formed our sun long ago. An interstellar visitor is completely different. It is a sample from somewhere else. It carries clues about how other stars and planets are born. It's like getting a letter from a pen pal in a country you've never visited. The letter tells you about their home, their food, their life. This object is a letter from the stars. The journey of 3I Atlas into our neighbourhood was long and silent. It likely travelled for millions of years, crossing the vast empty space between the stars. It moved through darkness, unseen and unknown. Then, it entered the gravitational pull of our sun. It was caught gently at first by the invisible hand of our star's gravity. Its path began to curve. That's how we find these things. Astronomers use powerful telescopes to scan the sky every night. They are looking for tiny points of light that move against the background of fixed stars. Most of the time, these moving lights are familiar asteroids or comets from our own system, but sometimes they find one that's different. They find one moving too fast or on a path that is too strange. When astronomers first saw 3I Atlas, they knew it was special. They calculated its path. The math told a clear story. This object was not in a closed loop around our sun, like the planets are. The planets travel in circles or ovals called orbits. They are tied to the sun and will circle it forever. But 3I Atlas was on a different kind of path. It was a wide, open curve, a path called a hyperbolic orbit. Think of it like this. If you throw a ball up in the air, gravity pulls it back down. It's in an orbit, even if a short one. But if you could throw a ball so fast that it never fell back to Earth, it would fly away into space forever. That's a hyperbolic path. It means the object has enough speed to escape the sun's gravity. It's not a prisoner here, it's just passing through. This was the first big clue. An object on such a path must have come from outside our solar system. It was already moving fast when it got here, and our sun just bent its path a little before it continued on its way. The discovery was announced, and telescopes all over the world turned to look at this new visitor. The scientific community was buzzing with excitement. We had only ever confirmed 2 interstellar visitors before this one. The first was a strange cigar-shaped object called Oumuamua. The second was a more comet-like object named Borisov. Now we had a third chance to study a piece of another world. The name, 3I Atlas, tells its own story. The 3I means it is the third interstellar object ever discovered. The Atlas part comes from the name of the telescope system that first spotted it. It stands for Asteroid Terrestrial Impact Last Alert System. Its main job is to find asteroids that might be a danger to Earth. But in doing its job, it sometimes finds these amazing visitors from deep space. So the name tells us what it is and who found it. A simple name for an object that would soon prove to be anything but simple. The general path of 3I Atlas was mapped out. It would swing in from deep space, pass by the orbit of Mars, get very close to the Sun, and then swing back out, passing near Earth and Jupiter on its way out of our solar system. This path gave scientists a fantastic opportunity. It was like a guided tour. As it passed different points in our solar system, different instruments could study it. Satellites orbiting the Sun, rovers on Mars, telescopes on Earth, all would get a chance to see this traveller. The excitement was about more than just seeing something new. It was about answering some of the biggest questions we have. How are other solar systems built? Are the chemicals and materials the same everywhere, or is each star system unique? Is the stuff that makes life on Earth common in the galaxy, or is it rare? 3i Atlas held the potential to answer these questions. It was a frozen piece of a distant world, and as it got closer to our Sun, the Sun's heat would begin to unlock its secrets. The ice would turn to gas, releasing ancient materials that had been locked away for billions of years. Scientists prepared their instruments and waited. They were like detectives at the scene of a crime, waiting for the main clue to reveal itself. They tracked the tiny point of light as it moved closer and closer to the centre of our solar system. Every new piece of data was eagerly examined. Was it shaped like Oumuamua? Did it have a tail like Borisov? What was it made of? The initial observations showed it looked like a comet. It was releasing some gas and dust, creating a faint glow around it. It seemed at first to be a well-behaved interstellar comet. But this visitor was holding its secrets close. The real show was about to begin. The closer it got to the Sun, the stranger it would become. Its journey into our neighbourhood was just the first chapter of a mystery that would challenge everything we thought we knew about objects in space. The universe had sent us a puzzle, and the first piece was just being placed on the board. A mysterious visitor had arrived, and it was about to do something completely unexpected. The journey of 3i Atlas through our solar system was planned by the laws of gravity. Its path was a graceful, predictable arc, calculated by computers to the finest degree. Every observatory knew where to point their telescopes and when. They knew the date it would be closest to Mars, they knew the date it would be closest to the Sun, and they knew the date it would make its closest pass to Earth. It was a cosmic schedule, written in the language of physics. The object was an open book, or so it seemed. The scientists reading this book were about to be shocked by a chapter they never could have predicted. The story of 3i Atlas was not one of simple gravity and predictable paths. It was a story of defiance. It was a story of an object that refused to play by the rules. As it drew nearer to our star, this interstellar traveller began to reveal a nature so bizarre, so alien, that it left astronomers grasping for explanations. The quiet visitor was about to make a very loud statement, and the heart of that statement would happen during its closest and most dangerous moment, its encounter with the Sun. This was the moment that would turn a scientific curiosity into a profound mystery. The moment a simple comet became something much, much more. The quiet anticipation in control rooms around the world was about to be shattered by a blast of impossible light. You might think we've covered all the weirdness, but what if 3i Atlas is not just a comet, but something far more extraordinary? Every object that enters our solar system must face its greatest trial, a close encounter with the Sun. Our star is a giant ball of fire, a source of immense heat and light. For a small, frozen object from the dark cold of deep space, getting close to the Sun is a dramatic event. This moment is called perihelion. Peri means near, and helios means sun. It is the single point in an object's orbit where it is closest to the Sun. For 3i Atlas, this date was October 27, 2025. This was the day it would feel the full force of the Sun's power. It would be heated, blasted with radiation, and pulled by immense gravity. Scientists knew this would be the most important time to watch. This is when a comet reveals its true nature. The heat forces gas and dust to erupt from its surface, creating the beautiful tails we associate with comets. By studying this gas and dust, we can learn what the comet is made of. A fleet of robotic eyes was waiting to watch this encounter. These are satellites that orbit the Sun, designed to watch it 24 hours a day. They are our solar watchdogs. One of them is NASA's Punch satellite. Punch is designed to watch the Sun's outer atmosphere, the corona, and the solar wind that flows from it. Other satellites like Stereo and SOHO have been watching the Sun for years. They have seen thousands of comets pass by the Sun. They know what a normal comet looks like. They know how a normal comet behaves. They were all pointed in the right direction, waiting for 3i Atlas to enter their field of view. They were ready to record a normal event. What they saw was anything but normal. As 3i Atlas approached its perihelion, it began to brighten. This was expected. A comet is like a dirty snowball. As it gets closer to a fire, the ice starts to melt and turn into steam. This steam, or gas, expands around the comet, creating a cloud called a coma. This cloud reflects sunlight, making the comet look brighter. The closer it gets, the more gas is released, and the brighter it becomes. This relationship between distance and brightness is a well-understood rule of comet behavior. Scientists have equations that predict exactly how bright a comet should get based on its distance from the Sun. But 3i Atlas did not follow the rules. It didn't just get brighter, it exploded with light. The data started to stream back from the satellites. On computer screens in labs across the world, a line on a graph began to move. This line represented the brightness of 3i Atlas. It was supposed to be a gentle upward curve. Instead, it was a vertical line. The object's brightness was increasing at a shocking rate. It became 10 times brighter than predicted, then 100 times. The numbers were so extreme that some scientists thought there must be a mistake. Maybe there was an error with the instruments. Maybe a solar flare was interfering with the data. But all the satellites were telling the same story. Punch saw it. Stereo saw it. Soho saw it. There was no mistake. 3i Atlas was undergoing a brightness blast. To put this in perspective, imagine you're walking towards a single candle in a dark room. As you get closer, the candle appears brighter. If you cut the distance in half, the candle will appear 4 times brighter. This is a basic law of physics. Comets are a bit more complex, but they generally follow a similar rule. They get a predictable amount brighter as they get closer to the Sun. 3i Atlas shattered this rule. Its brightness was tied to its distance from the Sun raised to the power of negative 7.5. That's a complicated way of saying that for every small step it took closer to the Sun, it got massively, outrageously brighter. It was as if that candle in the dark room suddenly turned into a searchlight, and then into a lighthouse beacon. The amount of light it was putting out was simply unbelievable for a small, icy body. This was not just a small deviation from the models. This was a complete break from everything we knew. No comet from our solar system has ever been observed to brighten this dramatically. It was an event without precedent. The initial excitement of seeing a new interstellar object turned into a state of profound confusion and wonder. What could possibly cause such an extreme reaction to the Sun's heat? Was the object breaking apart? Was it having some kind of chemical reaction that we had never seen before? The scientists who had been waiting for a simple comet flyby were now faced with a major astronomical puzzle. The object was not just a messenger from another star system. It was a rule breaker. It was a mystery wrapped in a blindingly bright cloud of light. The days following the perihelion were filled with frantic work. Scientists rechecked their data. They ran their models again and again. But the result was always the same. 3i Atlas had done something extraordinary. The brightness blast was real. The question was no longer what happened, but why. What was this object made of? What secret was hidden beneath its surface that could cause such a spectacular display? The simple act of passing near our Sun had turned 3i Atlas into one of the most mysterious objects ever seen in the sky. Its closest encounter was over, but the mystery was just beginning. The bright flash of light it left behind was like the flash from a camera, capturing a moment of pure impossibility, a moment that would force us to rethink the very nature of what a comet can be. The visitor was no longer just a visitor, it was a phenomenon, and it demanded an explanation. The extreme brightening of 3i Atlas left the scientific community in a state of shock. A brightness curve that's steep, that extreme, was not in any of the textbooks. It defied the standard models of cometary behavior. The immediate task was to try and find an explanation. How could a small, icy body produce so much light? The answers couldn't be simple, because the event itself was anything but simple. Scientists around the world began to propose ideas, trying to fit this strange new piece of data into our understanding of the universe. The theories that emerged fell into 2 main categories. Either the comet was doing something normal in a very extreme way, or it was made of something completely new and strange. The first and most straightforward explanation was that 3I Atlas was simply releasing a huge amount of gas and dust. This is what comets do, but this one might have done it on a scale never seen before. Imagine a can of soda. If you open it normally, you get a little fizz. That's a normal comet. Now imagine you shake that can of soda as hard as you can for a full minute, then throw it into a fire. The can would explode, releasing a massive cloud of foam. This theory suggests that 3I Atlas was like that shaken can of soda. The sun's heat was the fire, and it caused a huge, explosive release of material from inside the comet. This cloud of gas and dust would be enormous, and it would reflect a huge amount of sunlight, making the object appear incredibly bright. This idea is called strong activity. It suggests that the comet was not just gently steaming, but was actively erupting. Perhaps large pockets of ice trapped deep inside the comet were suddenly heated. This ice would flash into gas, and the pressure would build up until it exploded, tearing off a chunk of the comet's surface and throwing it into space. If this happened all over the comet at once, it could create the brightness blast that was observed. It's a plausible theory because it uses processes we already know happen on comets. It just pushes the scale of those processes to an extreme limit. To make this theory work, 3I Atlas would have had to lose a significant amount of its total mass in just a few days. It would have been shedding material at a ferocious rate. The second main theory was more exotic. It suggested that the extreme brightening was not just about the amount of material being released, but about the type of material. What if 3I Atlas had a very unusual chemical makeup? What if it was made of substances that we don't typically find in comets in our own solar system? Perhaps it contained chemicals that react very strongly and very brightly to the sun's heat and radiation. Think of a piece of magnesium. If you hold it in a flame, it doesn't just glow or melt. It bursts into an intensely brilliant white light. What if 3I Atlas had a surface, or an interior made of some cosmic equivalent of magnesium? A material that, when heated to a certain temperature, undergoes a rapid chemical change that releases a huge amount of energy in the form of light. This theory is compelling because it could explain the sheer intensity of the brightening. A simple release of dust and gas might struggle to explain the off-the-charts numbers that the satellites recorded. A chemical reaction, however, could provide the extra energy needed. The problem with this theory is that it requires us to imagine materials or combinations of materials that we have never seen before. If this is the case, then 3I Atlas is not just a piece of another solar system, it's a piece of a truly alien chemical factory. It would mean that the building blocks of other star systems could be fundamentally different from our own. This is a thrilling but also a challenging idea. Without a sample of the object to study in a lab, it is very hard to prove what kind of strange chemistry might be at work. Both of these theories had to contend with one major problem: the uniqueness of the event. Why is such extreme brightening so unheard of? We have observed thousands of comets in our own solar system. They pass by the sun all the time. Some of them are big, some are small, some are very active, and some are quiet. But none of them have ever brightened like 3I Atlas. None have shown a brightness curve proportional to the distance raised to the power of -7.5. This suggests that 3I Atlas is not just another comet. It is special. It is different. If the strong activity theory is correct, then why is 3I Atlas so much more active than any other comet? If the unusual chemistry theory is correct, then what is that chemistry, and where did it come from? The mystery of the brightness blast was not a simple one to solve. It was a clue that pointed to the very heart of what 3I Atlas is. It wasn't just a side effect of its journey, it was a defining characteristic. The object was screaming for attention, announcing its presence with a flare of light that broke all the rules. It was a challenge to astronomers, a challenge that said, "You think you know how the universe works? Look at me." The scientists had their theories: gas, dust, or something else entirely. But they were just theories. They needed more data, more clues, and as they would soon discover, 3I Atlas had more surprises in store. The brightness blast near the sun was the most dramatic event, but it was not the only one. This strange behaviour was part of a pattern that would make this mysterious visitor even more puzzling. The search for answers had only just begun, and the object was already 2 steps ahead. In the world of science, a single strange event can sometimes be dismissed. It might be a fluke, a 1 in a million occurrence, or even an error in the data. But when that strange event happens more than once, it becomes a pattern. And a pattern cannot be ignored. A pattern is a clue. It tells you that what you are seeing is not random, but is a fundamental part of the object's nature. After the shocking brightness blast near the Sun, scientists went back and looked at all the data they had collected on 3I Atlas since its discovery. They wanted to see if there were any earlier signs of its strange behaviour. They found one. The encounter with the Sun was not the first time 3I Atlas had acted strangely. It had put on a similar, smaller show when it passed by the planet Mars. Long before it reached the Sun, 3I Atlas had to travel through the outer parts of our solar system. Its path brought it relatively close to the orbit of Mars. At that distance, the Sun's warmth is much weaker. It is a cold, dark region of space. A typical comet is mostly dormant that far out. It's usually just a dark, frozen chunk of ice and rock, reflecting a tiny amount of sunlight. We wouldn't expect to see much activity. We wouldn't expect it to be very bright. But when astronomers looked back at the observations of 3I Atlas as it approached Mars, they saw something familiar. It had undergone a small outburst. It had suddenly and unexpectedly become brighter than it was supposed to be. The Mars flyby anomaly was not as dramatic as the brightness blast near the Sun. It was a much smaller event, but it was the same kind of event. The object's brightness increased more than the models predicted. It was like a small preview of the main event that was to come. It was like a volcano rumbling and smoking a little before a major eruption. At the time, this small brightening might have been overlooked or considered just a minor oddity. Comets can have small outbursts. But seen in the light of what happened at perihelion, the Mars flyby took on a new significance. It was a critical piece of the puzzle. This discovery was incredibly important. It proved that the extreme brightening was not a one-time event, caused by some unique condition right next to the Sun. It was a repeated behaviour. It was something this object just does. It has a tendency to react much more strongly to sunlight than any normal comet, even when that sunlight is weak. This made the mystery even deeper. The strong activity theory, the idea of huge gas and dust releases, now had to explain how this could happen so far away from the Sun, where the heating is minimal. The unusual chemistry theory now seemed more likely. Perhaps the object was coated in a frost of some highly volatile material, a substance that turns to gas at very low temperatures. When the faint sunlight near Mars hit this frost, it could have caused the small outburst. Then, when the much stronger sunlight near the Sun hit the main body, it caused the massive brightness blast. This repeating pattern created a huge amount of puzzlement among scientists. They were dealing with an object that seemed to have its own set of rules. It was consistently, predictably strange. The consistency was key. It ruled out simple explanations like a random collision with a small piece of space debris. That might explain one outburst, but not two. This was something internal to 3I Atlas. It was part of its very being. The puzzle was no longer just, why did it get so bright near the Sun? It was now, what is this object made of that causes it to have these outbursts whenever it receives a significant amount of sunlight? Imagine you have a new friend who is very quiet. One day someone tells a joke, and your friend lets out a laugh so loud it shakes the room. You might think it's a one-time thing. But then, a week later, someone tells another joke, and your friend does it again. Now you know, this is not a quiet person. This is a person with a surprisingly loud laugh. You have learned something fundamental about their personality. Scientists had just learned something fundamental about the personality of 3I Atlas. It was an object that looked quiet from a distance, but had a shockingly explosive reaction to warmth. This consistent, unexpected brightening pattern became a central focus of the investigation. It connected the different parts of the object's journey. The Mars flyby and the Sun encounter were now linked as two examples of the same strange phenomenon. This pattern gave the researchers a solid, repeatable piece of data to work with. They could now try to create new models that could account for this behaviour. What kind of material would sublimate, or turn from solid to gas, both near Mars and near the Sun in just this way? Could it be layers of different ices, a core that is unusually hot? The theories became more complex as they tried to explain this repeating pattern of weirdness. The story of 3I Atlas was becoming a story of mounting evidence. Each new observation didn't solve the mystery, but instead added a new, confusing layer to it. First, it was an interstellar visitor. Then, it was a visitor that exploded with light near the sun. Now it was a visitor that had a history of these explosions. The object was building a case for its own strangeness, and this was just the beginning. The brightness anomaly was the most visible clue, but there was another, more subtle clue hidden in the data. A clue that was, in some ways, even more profound. It wasn't about the light it was giving off, it was about the way it was moving. 3i Atlas wasn't just breaking the rules of brightness, it was breaking the most fundamental rule of all, the law of gravity. In the precise and predictable dance of the cosmos, gravity is king. Everything in the universe pulls on everything else. Planets pull on moons, stars pull on planets, galaxies pull on each other. This invisible force is what holds everything together. For centuries we have been able to predict the movements of celestial bodies with incredible accuracy using Isaac Newton's law of universal gravitation. We can send a spacecraft from Earth and have it arrive at Mars months later at a precise location and time. We can do this because we understand gravity. We know its rules. The path of any object in space, from a tiny asteroid to a giant planet, should be perfectly predictable if you know where it is, how fast it is going, and what gravitational forces are pulling on it. But 3i Atlas was not being perfectly predictable. It was straying from its path. Something other than gravity was giving it a push. This discovery was one of the most astounding to come from the study of 3i Atlas. Scientists at NASA's Jet Propulsion Laboratory, or JPL, are the world's experts at tracking objects in space. It is their job to calculate the orbits of asteroids, comets, and spacecraft. They are masters of the math of gravity. As they tracked 3i Atlas, they noticed something strange. The object was not exactly where their calculations said it should be. The difference was tiny, almost unnoticeable. But with the incredible precision of their tools, they could measure it. 3i Atlas was slightly ahead on its orbital path. It was moving just a little bit faster than gravity alone could explain. This tiny extra push is known as non-gravitational acceleration. It means that some force besides the pull of the sun and the planets was acting on the object. To understand why this is such a big deal, imagine you're rolling a bowling ball down a very long, perfectly smooth hallway. You know exactly how hard you pushed it, so you can calculate exactly where it should be at any given second. Now imagine you check on it a minute later, and it's a few inches further down the hallway than it should be. You would be puzzled. You would know that some other force must have acted on it. Was there a slight breeze you didn't notice? Is the floor tilted in a way you can't see? You would need to find the source of that extra push. Scientists at JPL were in the same position. They saw that 3i Atlas was a few inches ahead of where it should be on its cosmic bowling lane. They needed to find the reason. Even a very small push can have a huge effect over the vast distances and long timescales of space travel. A tiny nudge every second can add up to a big change in position over weeks and months. This is why orbital calculations have to be so precise, and it's why the discovery of any non-gravitational force is so important. It tells us that our simple model of gravity is not the whole story for this object. There is another character on the stage, another force at play, and we need to figure out what it is. This is not a common occurrence. Most asteroids and planets follow the rules of gravity perfectly. The mysterious push was another clue that 3i Atlas was not a simple rock. The confirmation of this extra acceleration came from careful analysis of data collected over many months. By comparing the object's predicted position with its actual, observed position, scientists could build a clear picture of this extra force. They could measure its strength and even its direction. The force was very weak, much weaker than the pull of the sun's gravity. But it was constant, and it was real. The data was undeniable. NASA's Jet Propulsion Laboratory, the gold standard for this kind of work, had confirmed it. 3i Atlas was defying gravity. This discovery opened up a whole new line of questioning. The mysteries were no longer just about its brightness or its chemical makeup. Now it was about its very motion through space. What could be powerful enough to push a comet even a little bit? What kind of engine, natural or otherwise, could be at work? The implications were huge. An object that can generate its own push is a much more complex and interesting object than one that is simply a slave to gravity. It has its own agency, its own internal process that affects its journey. The mysterious push became the second major anomaly, alongside the extreme brightening, and the two might even be connected. Perhaps whatever was causing the object to become so bright was also the source of the push. This seemed like a promising lead. The detectives of astronomy now had two key clues: a suspect that flashed an impossibly bright light, and a getaway car that was moving just a little too fast. The job was to connect the two, to find a single theory that could explain both the light show and the mysterious push. The search for that theory would lead scientists to consider a process that is common in comets, but, like everything else with 3i Atlas, might be happening on a level that was completely off the charts. The most likely explanation was a simple process, a process that acts like tiny rocket thrusters all over the comet's surface, a process called outgassing. When faced with a mystery, scientists prefer to start with the simplest, most likely explanations. Before jumping to wild conclusions, they must first rule out the normal ones. For the mysterious push, the non-gravitational acceleration seen in 3i Atlas, there was one very obvious and very normal explanation to consider first. This explanation is called outgassing. It's a process that happens with almost every comet that gets close to the Sun, and it is the leading theory for why 3i Atlas was straying from its path. So, what is outgassing? The explanation is quite simple. Most comets are made of a mix of rock, dust, and various kinds of ice, like frozen water, carbon dioxide, and carbon monoxide. They're often called dirty snowballs. For most of their lives, in the cold, dark depths of space, they are completely frozen and inactive. But when a comet's orbit brings it closer to the Sun, things start to change. The Sun's heat warms the surface of the comet. As the surface warms, the ice that is trapped there doesn't melt into a liquid. In the vacuum of space, it goes directly from a solid to a gas. This process is called sublimation. As this ice turns into gas, it erupts from the surface. It shoots out into space in jets and plumes. These escaping gases create a small but measurable thrust. It works exactly like a tiny rocket engine. Imagine you are sitting in a chair with wheels in the middle of a room, and you throw a heavy ball forward. The act of throwing the ball will push you and your chair backward. This is Newton's third law of motion. For every action, there is an equal and opposite reaction. The gas escaping from the comet is like that thrown ball. As the gas shoots out in one direction, it pushes the comet in the opposite direction. If there are many of these gas jets all over the comet's surface, they can work together to give the comet a small, continuous push. This push is the non-gravitational acceleration. This is the most likely explanation for the mysterious push on 3i Atlas because we have seen it happen with many other comets. It's a known and understood phenomenon. The Rosetta mission, for example, flew alongside a comet for years and watched these gas jets erupting from its surface in incredible detail. So, the idea that outgassing is pushing 3i Atlas is not a strange one. It's the standard model. The question is not whether outgassing is happening. The question is whether it can explain the specific push that we see. To confirm this theory, scientists need to do two things. First, they need to see direct evidence of the outgassing. They need to be able to see the jets of gas and dust coming off the comet. When 3i Atlas was very close to the Sun, it was so bright and surrounded by such a large cloud of material that it was hard to see the surface. But as it moves away from the Sun and gets closer to Earth, our telescopes will have a better view. Scientists will use powerful instruments to look for the telltale signs of gas plumes. They will also use spectrometers to analyze the light from the comet, which can tell them what kinds of gases are being released. If they find large amounts of water vapor, carbon dioxide, or other common comet gases, it will be strong evidence for the outgassing theory. Second, the numbers have to add up. Scientists need to measure exactly how much gas is being released and in what direction. Then, they can calculate how much thrust this outgassing would produce. They can then compare that calculated thrust to the observed non-gravitational acceleration that was measured by JPL. If the two numbers match, then the case is closed. The mysterious push is not so mysterious after all. It's just outgassing. The challenge is that this is very hard to do. The comet is far away, and the push is very small. The measurements have to be incredibly accurate. So outgassing is the leading suspect. It's the usual culprit for this kind of behavior. But 3i Atlas is not a usual comet. Everything it does to an extreme. So it's possible that while outgassing is happening, it might not be the whole story. Perhaps the amount of outgassing needed to produce the observed push is simply too large. It would mean the comet is losing an unrealistic amount of its mass. or perhaps the direction of the push doesn't match the direction we would expect from outgassing. The jets of gas are usually released from the sunlit side of the comet, where the heating is strongest. This should result in a push in a particular direction. If the observed push is in a different direction, then outgassing alone can't be the answer. For now, the scientific community is waiting. They are waiting for 3i Atlas to become visible again in our telescopes, free from the glare of the sun. They are preparing their instruments for the most detailed observations yet. The outgassing theory is the first thing they will try to confirm. It is the simplest and most elegant explanation. It would neatly solve the puzzle of the mysterious push. But with an object as strange as 3i Atlas, the simplest explanation is not always the right one. And if the data shows that outgassing is not enough, then the mystery deepens, and scientists will be forced to look beyond the standard explanations and into the realm of new and extraordinary possibilities. The outgassing theory is a comfortable one. It fits within our current understanding of comets and the laws of physics. It explains the mysterious push using a known natural process. But science is not about being comfortable. It's about following the evidence, even when it leads to uncomfortable or strange places. So we must ask the question, what if outgassing isn't enough? What if, when we get a better look at 3i Atlas, we find that the numbers just don't add up? What if the push it is experiencing is too strong, or in the wrong direction, to be explained by escaping gas alone? If that happens, then we are in truly new territory. We would be forced to consider possibilities that go beyond our standard models. This is not just a theoretical exercise. We have been in this exact situation before. The first interstellar visitor, Oumuamua, also showed a small non-gravitational acceleration. Just like 3i Atlas, it was moving in a way that gravity alone could not explain. The immediate explanation, of course, was outgassing. But there was a problem. Telescopes looked very closely at Oumuamua, and they saw no sign of outgassing. There was no fuzzy coma of gas and dust around it. There was no tail. It looked like a simple, inert piece of rock. But it was being pushed. How can you have the push of outgassing without any of the gas? This was the central mystery of Oumuamua. It left scientists with a puzzle, a comet that pushed like a comet, but didn't look like a comet. The debate over Oumuamua opened the door to more exotic ideas. Because the simple, natural explanation didn't seem to fit the facts, some scientists were forced to get creative. They had to think about new possibilities. Could the object be made of something we've never seen before, like a solid hydrogen iceberg, which would produce a gas that is transparent and hard to detect? Or could it be something even stranger? The lack of a simple explanation for Oumuamua's push is what led some, like Harvard professor Avi Loeb, to suggest that we should consider the possibility that it was not a natural object at all. He argued that an object that was very thin and light, like a sail, could be pushed by the pressure of sunlight itself, with no outgassing needed. This was a controversial idea, but it was born from a failure of the standard explanations. Now with 3i Atlas, we might be facing a similar situation. We have the mysterious push. We have the leading theory of outgassing, but we also have the extreme, unprecedented brightening. The two might be linked. Perhaps the massive release of gas and dust that caused the brightness blast was also responsible for the push. This seems to make sense. But what if the timing is wrong? What if the push was constant, even when the object wasn't having a major outburst? Or what if the strength of the push doesn't correlate with the brightness? If there are inconsistencies like these, then the simple link between outgassing and the push starts to fall apart. Let's imagine what an unexpected result might look like. Scientists measure the amount of gas coming off 3i Atlas. They calculate that it should be producing a certain amount of thrust, but when they look at the object's orbit, they find that the actual push is 10 times stronger than their calculation. That would be a huge problem for the outgassing theory. It would mean that 90% of the force is coming from somewhere else, an unknown force. Or, imagine they measure the direction of the gas jets. They are mostly coming from the front of the comet, pushing it backward and slowing it down. But the orbital data shows that the comet is actually speeding up. This would be a direct contradiction. The push is in the wrong direction. If a result like this comes in, it would be a major scientific moment. It would mean that our understanding of interstellar objects is incomplete. It would force us to rethink our assumptions, just as Oumuamua did. We would have to start considering those new possibilities again. Could the push be caused by magnetic fields interacting with the solar wind? Could it be related to the object's strange chemical composition? Or would we once again be forced to consider the more radical ideas? An object that generates its own propulsion is, by definition, a machine. It's a spacecraft. Now, this is a huge leap, and it is not a conclusion that any scientist would jump to lightly. But if all natural explanations fail, it is a possibility that remains on the table, however unlikely. The story of 3i Atlas is therefore at a crossroads. Its future study will be a critical test of the outgassing theory. If the theory holds up, then 3i Atlas will go down in history as a very strange and unusually active comet, but a comet nonetheless. It will teach us about the extreme range of behaviours that natural objects can have. But if the outgassing theory fails, if it is not enough to explain the mysterious push, then 3i Atlas will become something much more. It will join Oumuamua as a truly profound mystery, an object that defies simple explanation and points towards new physics, or perhaps something even more transformative. The stakes are high, and the universe is waiting to show us its hand. As scientists grapple with the extreme behaviour of 3i Atlas, some are willing to push the boundaries of conventional thinking. One of the most prominent voices in this area is Avi Loeb, a professor of astronomy at Harvard University. He is known for his bold ideas, especially regarding the search for extraterrestrial intelligence. He gained fame for his controversial suggestion that Oumuamua might have been an alien artifact. When it comes to 3i Atlas, he has not made such a claim, but he has applied his signature style of logical, out-of-the-box thinking to its many mysteries. His insights help to frame the key questions that need to be answered and highlight the extraordinary nature of what we are seeing. One of Loeb's key points focuses on the consequences of the outgassing theory. He agrees that outgassing is the most likely explanation for the non-gravitational push, but he takes the idea to its logical conclusion. If outgassing is responsible for both the extreme brightening and the mysterious push, then the amount of material being released must have been truly enormous. The brightness blast was not a small event. It was a spectacular one. To produce that much light by reflecting sunlight off a cloud of gas and dust, that cloud would have to be immense. This means the comet must have lost a huge amount of its own substance in a very short amount of time. This is what Loeb calls rapid mass loss. He argues that this is a testable prediction. If 3i Atlas really did shed a significant fraction of its mass during its close approach to the Sun, then we should be able to see the consequences. The object itself might have gotten smaller, or its shape might have changed, or it might be surrounded by a large expanding cloud of debris that is now separating from the main body. When 3i Atlas gets closer to Earth, astronomers will have a chance to test this. They can use powerful telescopes to carefully measure its size and shape. They can compare these new measurements with the measurements taken before it passed the Sun. If they find that the object is noticeably smaller, or if they see a large cloud of disconnected debris, it would be strong evidence in favour of the extreme outgassing theory. But Loeb also raises the alternative. What if we look and we don't see any evidence of this rapid mass loss? What if 3i Atlas looks just as solid and intact as it did before? What if it hasn't lost a huge amount of material? If that's the case, then we have a major problem. We would have an object that produced a huge cloud of light and experienced a mysterious push, all without losing much of its own substance. This would be a contradiction. It would be like a rocket engine that produces thrust without using any fuel. This is where Loeb's thinking ventures into more controversial territory. He suggests that if the data doesn't match the predictions of the natural outgassing model, we must be open to other ideas. This is where he brings up the concept of a thin spacecraft-like structure. This idea comes directly from his work on Oumuamua. The theory is that a very thin, very lightweight object with a large surface area could be pushed by the pressure of sunlight itself. This force is called solar radiation pressure. It is a very weak force, but over a large area it can be significant. It is the principle behind the idea of a solar sail, a way to propel spacecraft through space using only sunlight. A natural object, like a rocky asteroid or an icy comet, is usually too thick and heavy for solar radiation pressure to have much of an effect. It's like trying to move a bowling ball by blowing on it. But a very thin, light object, like a piece of aluminum foil the size of a football field, could be pushed, effectively. It's like a sail catching the wind. Loeb's controversial point is that nature doesn't tend to make objects that are very thin and have a large surface area. Rocks are lumpy, comets are lumpy. But technologies like sails or solar panels are often thin and flat. So if we were to find an object that was being pushed by sunlight in a way that suggested it had this kind of structure, it would be a sign that it might be artificial. He is not saying that 3i Atlas is a spacecraft. He is saying that this is a hypothesis that should be considered if the more conventional theories fail. His argument is a logical one. If the outgassing model requires rapid mass loss, and we don't see any evidence of that mass loss, then we need a different model. A thin structure pushed by sunlight is one such model. This way of thinking is what makes Avi Loeb both a celebrated and a controversial figure. He is willing to publicly discuss possibilities that many scientists might only think about in private. He forces the community to confront the strange data head-on, and not to shy away from its implications, no matter how wild they may seem. He is not providing answers. He is providing sharp, testable questions. Is there evidence of mass loss? Yes or no? If yes, the outgassing theory is strengthened. If no, we have a serious problem that requires a new explanation. The idea of a spacecraft might be a long shot, a 1 in a billion chance. But as Loeb often says, if we don't look for evidence of the extraordinary, we will certainly never find it. 3i Atlas, with its growing list of anomalies, is giving us plenty of reasons to look. As if an extreme brightness blast and a mysterious push against gravity weren't enough, 3i Atlas had another, even more baffling secret to reveal. This secret came not from its motion or the amount of light it was giving off, but from the very colour of that light. As scientists analysed the images taken by the solar observatories, the satellites watching the sun, they noticed something that at first seemed impossible. The images showed that 3i Atlas appeared to be bluer than the sun. This simple 3-word description hides a profound and deeply puzzling scientific anomaly. It is perhaps the strangest clue in the entire mystery of this object. To understand why this is so weird, we need to think about what colour means in astronomy. When we look at an object in space, the colour we see depends on two things: the light that is hitting it and the way the object's surface reflects that light. Most of the objects in our solar system, like planets, asteroids and comets, don't produce their own light. They are visible because they reflect the light of our sun. The sun's light is a mix of all the colours of the rainbow, which we see as a yellowish-white light. When this sunlight hits an object, some colours are absorbed and some are reflected. The colours that are reflected are what we see. An object that looks red, for example, is reflecting more red light and absorbing more blue and green light. In our solar system, most rocky and icy bodies tend to be reddish. This is for a couple of reasons. First, the dust and rough surfaces of asteroids and comets tend to scatter red light more effectively than blue light. This is a common physical process. Second, objects that are cooler than the source of light that is shining on them will generally appear redder. Think about a piece of iron. At room temperature, it's grey. As you heat it up, it starts to glow a dull red. As it gets hotter, it becomes orange, then yellow, then white, and if you could get it hot enough, it would glow blue-white. The colour is directly related to the temperature. The sun's surface is about 10,000 degrees Fahrenheit, which gives it its yellowish-white colour. A comet, even one very close to the sun, is much, much cooler than that. Therefore, we would expect it to reflect the sun's light in a way that makes it look either the same colour as the sun, or, more likely, slightly redder. The satellites that observed 3i Atlas, like SOHO and Stereo, are equipped with special cameras called coronagraphs. These cameras are designed to block out the overwhelming light of the sun itself so that they can see the faint outer atmosphere, the corona, and any objects, like comets, that are flying by. These cameras take pictures using different colour filters, allowing scientists to measure the precise colour of the objects they see. When they did this for 3i Atlas, they got a result that made no sense. The data showed that the object was giving off proportionally more blue light and less red light than the sun itself. It was bluer than its source of illumination. This is a deeply strange result. How can an object be bluer than the light that is shining on it? It's like shining a yellow flashlight on a wall and seeing a blue spot. It breaks our intuition about how light and reflection work. The first thought, of course, was that it must be an error, some kind of problem with the instruments or the way the data was processed. But the observation was confirmed by multiple instruments on multiple satellites. The blue colour was real. The discovery sent ripples of confusion through the scientific community. There is no known natural object in our solar system that behaves this way. Dust makes things redder. Cold makes things redder. 3i Atlas was defying the known rules of optics. What could possibly explain this? The theories are few and far between, and they are all exotic. One possibility is that the object is not just reflecting sunlight. It might be producing its own light through a process called fluorescence. This is when a material absorbs light of one colour, like the sun's ultraviolet light, and then emits light of a different colour, like visible blue light. Some materials on Earth do this, but to produce enough blue light to overwhelm the reflected sunlight and make the whole object appear blue would require a very specific and highly efficient fluorescent material of a kind we've never seen on a comet before. Another possibility is that the dust particles coming off the comet have a very strange size and shape that causes them to scatter blue light in a highly unusual way. But again, this would be a type of dust that is completely unknown to us. The blue mystery adds a completely new dimension to the puzzle of 3i Atlas. It is not just about its orbit or its brightness, it is about its fundamental physical nature. The object's surface, or the material it is made of, is interacting with sunlight in a way that is alien to our experience. It suggests that the very stuff this object is made of is different from the stuff that makes up our corner of the universe. This single strange fact, bluer than the sun, is a powerful piece of evidence. It tells us that we are not just looking at a weird comet. We are looking at something that challenges our basic understanding of chemistry and physics in space. And it opens the door to an even more mind-bending question, a question posed by Loeb. If an object is bluer and brighter than the sun, could it be because it is hotter than the sun? The observation that 3i Atlas appeared bluer than the sun was more than just a curiosity. It was a clue that pointed to something deeply strange about the object's physical nature. This single piece of data raised a question that is so far outside the realm of normal astronomy that it sounds like science fiction. The question, which was most directly posed by Professor Loeb, is this: could 3i Atlas be using a power source that is hotter than the surface of the sun? This is a truly mind-bending possibility, but it flows directly and logically from the evidence of the object's strange blue colour. Let's break down the logic. In the universe, the colour of an object that produces its own light is directly related to its temperature. This is a fundamental law of physics known as black body radiation. Think of the heating element on an electric stove. When you turn it on, it first starts to glow a dull red. This is the coolest visible temperature. As you turn the heat up, it becomes a brighter orange red. If you could get it much, much hotter, it would turn yellow, then white, and eventually it would glow with a brilliant blue-white light. Blue light has more energy than red light, so an object must be hotter to produce it. Stars are a perfect example of this. Cool, dim stars are red. Our sun, which is hotter, is yellowish-white. The hottest, most massive stars in the universe are a brilliant blue. Colour equals temperature. Our sun's surface temperature is about 10,000 degrees Fahrenheit, or 5,500 degrees Celsius. This temperature produces a specific spectrum of light, a specific mix of colours that our eyes see as yellowish-white. Now consider 3i Atlas. It was observed to be bluer than the sun. If 3i Atlas was just a cold object reflecting sunlight, this should be impossible. A reflection cannot be bluer than the original light source. It's like trying to get a blue reflection from a yellow lamp. But what if 3i Atlas wasn't just reflecting light? What if it was generating its own light? For it to appear bluer than the sun, the source of that light would have to have a temperature that is hotter than the sun's surface. This is a shocking conclusion. A small, comet-sized object generating temperatures in excess of 10,000 degrees Fahrenheit would be an unprecedented discovery. Natural comets are icy bodies. They are cold. Their activity is caused by the sun's heat boiling away their ices, but the objects themselves do not generate their own heat. So, if 3i Atlas was generating this kind of heat, it would have to be through some process that is completely unknown to us. It could not be a normal comet. So, what are the possibilities? Loeb's question forces us to think about what kind of power source could be contained within a small object and produce such temperatures. In nature, the only things we know of that are this hot are stars, but 3i Atlas is clearly not a star. It's tiny. Could it be some kind of exotic chemical reaction? Far more energetic than anything we've considered before? Perhaps. Could it be related to nuclear energy? The energy that powers stars is nuclear fusion, but that requires immense size and pressure. A small object would not be able to sustain fusion. Could it be a piece of some incredibly exotic object, like a neutron star? A piece of a neutron star would be incredibly dense and could be hot, but it would behave in other ways that we have not observed. All of the natural explanations are extremely difficult to imagine. This, of course, leads to the most speculative and controversial possibility. If an object is small, travels between the stars, and has its own power source that generates more heat than the surface of a star, the most straightforward, if unsettling description for such an object would be an advanced piece of technology, a probe, a machine, an engine. In our own technology, we create things that are much hotter than their surroundings. The filament in an old light bulb is much hotter than the lamp it is in. A jet engine's exhaust is hotter than the air around it. Technology is, in many ways, the art of concentrating energy to create localized high temperatures. This is not to say that 3i Atlas is an alien engine. That is a giant leap in logic. But the bluer than the sun observation, when taken seriously, forces us to at least walk up to the edge of that leap and look down. It adds a powerful new anomaly to the growing list of strange behaviors. We have an object that brightens more than it should. It moves in a way it shouldn't, and it has a color that it shouldn't. The mystery of the push could perhaps be explained by outgassing. The mystery of the brightening could be explained by extreme outgassing, but the mystery of the color is much harder to explain away with any standard comet model. The blue anomaly stands apart. It might be the most important clue of all. It points away from simple chemistry and towards a more complex physical process. Avi Loeb's question about a power source hotter than the sun is not a claim. It is a challenge. It challenges the scientific community to find a natural explanation for this seemingly impossible observation. If they can, it will be a major breakthrough in our understanding of planetary science. But if they can't, then the mystery of 3i Atlas will remain, a tiny blue speck in a vast universe of questions, hinting at possibilities that are as exciting as they are profound. Just when it seemed that 3i Atlas could not possibly get any stranger, it did. Before the object passed behind the sun and disappeared from our view for a time, it displayed a few more bizarre behaviors. These were not as dramatic as the brightness blast or as fundamental as the mysterious push, but they were just as puzzling. They were details, but in a detective story, it is often the small, strange details that hold the key. The final observations of 3i Atlas before its perihelion added two more items to the list of anomalies: a tail that flipped its direction and a unique way of scattering light that had never been seen before. The first of these new mysteries involved the comet's tail. Comets typically have two tails. One is the ion tail, made of gas that is pushed straight away from the sun by the solar wind. The other is the dust tail, made of heavier dust particles that are pushed more gently by the pressure of sunlight. This dust tail is often curved and follows along the comet's orbital path. Both of these tails always point generally away from the sun. It's the basic rule of comet tails. The sun's energy is what creates them, and it pushes them out, away from the source of that energy. But sometimes, from our perspective on Earth, we can see something that looks like a tail pointing towards the sun. This is called an anti-tail. An anti-tail is usually an optical illusion. It happens when we are looking at a comet's orbit edge-on. The dust that was released by the comet a long time ago is left behind on its orbital path. When we look at the comet, we see the new dust being pushed away from the sun to form the main tail, but we also see that trail of old dust stretching out behind the comet along its orbit. Depending on the geometry, this trail of old dust can appear to point towards the sun. It's not a separate tail, it's just a part of the main dust tail seen from a funny angle. Most anti-tails are faint and predictable, but the anti-tail of 3i Atlas was different. Observations showed that 3i Atlas had a faint but distinct dust stream that appeared to point towards the sun. This was its anti-tail. But what was strange was its behaviour. As the comet got closer and closer to the sun, approaching its perihelion, this anti-tail did something completely unexpected. It suddenly and rapidly flipped. The faint stream of dust that had been pointing toward the sun seemed to swing around and merge with the normal tail, which was pointing away from the sun. This sudden flip is not something that is understood by current models of comet tail dynamics. An antitail is made of old, heavy dust particles that should not be easily moved by the solar wind. Why would it suddenly change its direction so dramatically? It was another strange cinematic moment in the journey of this object, a flick of its tail that defied easy explanation. The second new anomaly was even more technical but just as strange. It had to do with the way the comet's dust scattered sunlight. Light from the sun is unpolarized, which means the light waves vibrate in all different directions. When this light bounces off a surface, like the dust particles around a comet, it can become polarized. This means that the reflected light waves tend to vibrate more in one particular direction. We use this principle in polarized sunglasses, which block out the polarized light that reflects off a road or a body of water, reducing glare. Scientists can use special filters on their telescopes to measure the amount and direction of polarization in the light from a comet. This tells them a lot about the size, shape, and texture of the dust particles. For all comets in our solar system, when we look at them from certain angles, we see a small amount of what is called negative polarization. It's a known, predictable feature. But when scientists measured the polarization of light from 3i Atlas, they found something new. It showed an extremely high degree of negative polarization, higher than has ever been recorded for any other comet. The effect was so strong that it was once again completely off the charts. This was not just a small difference, it was a fundamentally different optical property. This highly unusual polarization signature tells us that the dust particles coming off of 3i Atlas are unlike any dust we have ever studied. They are scattering light in a unique way. Perhaps they are a very strange size, or they have a very unusual complex shape, or maybe they are made of a material that has very strange optical properties. Whatever the reason, this measurement was a direct physical probe of the material of the comet itself, and it was telling us in no uncertain terms that this material is different. It's alien. This isn't just a comet that behaves strangely, it's a comet that is made of strange stuff. These two final anomalies, the flipping anti-tail and the extreme negative polarization, were the last clues we got before 3i Atlas swung behind the sun. They were like the final, cryptic words in the first part of a mystery novel. They didn't solve anything. They just added more layers of complexity and strangeness. They showed that the weirdness of 3i Atlas extends from its large-scale orbital dynamics all the way down to the microscopic properties of its individual dust, grains. Every way we look at this object, from every different angle, using every different tool, it shows us something new and unexpected. It is a puzzle from top to bottom. As it disappeared into the sun's glare, it left a trail of questions behind it, a trail as puzzling and strange as its own flipping, polarized tail. As 3i Atlas continued its journey, scientists began to analyze the light coming from it in more detail. By using an instrument called a spectrometer, they can break the light from a celestial object into its component colors, like a rainbow. This spectrum has dark or bright lines in it, which act like a chemical fingerprint. Each element and molecule absorbs and emits light at very specific colors, so by looking at the spectral lines, scientists can tell what an object is made of. The chemical analysis of 3i Atlas revealed yet another layer of strangeness. Its chemical makeup was not just a little bit unusual, it was bizarrely structured, like a cosmic object that had been assembled in layers. One of the first and most surprising discoveries was that 3i Atlas was surrounded by a kind of protective shell. This was not a solid shell, but a large invisible envelope of gas molecules that surrounded the inner coma. This shell was detected because it was absorbing certain colors of sunlight before that light reached the inner parts of the comet. This is not a typical feature of comets from our solar system. While comets have a coma, a cloud of gas and dust, this distinct, layered, protective shell was something new. It was as if the comet had its own personal atmosphere or force field, filtering the sunlight that hit it. The purpose or origin of this shell was a complete mystery, but it was just the first hint of the object's strange internal structure. When scientists looked at the chemical fingerprints of the material closer to the comet's nucleus, things got even weirder. They found that the inner region of the coma, the area closest to the solid body, was dominated by the element nickel. They could see the clear spectral signature of vaporized nickel atoms. This in itself is not shocking, as nickel is found in meteorites. But what was shocking was what was missing. In our solar system, and in meteorites that fall to Earth, nickel and iron are almost always found together, usually in a predictable ratio. They are chemically similar and tend to form together in the process of star and planet formation. But in the coma of 3I Atlas, there was a strong signal for nickel, but almost no signal for iron. It was as if something had managed to separate the two elements, a process that is very difficult to do in nature. It was like finding a forest with only oak trees and no pine trees. It was an unnatural-seeming separation of two things that should be together. Moving further out from the nucleus, the chemical composition changed. In a middle layer of the coma, scientists found that the dominant chemical signature was from cyanide, compounds. Cyanide, a molecule made of one carbon atom and one nitrogen atom, is found in many comets, but here it seemed to be concentrated in a specific region, a layer between the nickel-rich core and the outer coma. It wasn't just mixed in everywhere, it was in its own zone. This suggested that the part of the comet that was vaporizing to create this layer was particularly rich in cyanide-bearing ices, and then, in the outermost layer of the coma, the chemical signature changed again. Here, the dominant gases were carbon dioxide and carbon monoxide. These are very common gases in comets, as they are made from ices that turn to gas at very low temperatures. It made sense that these would be in the outer part of the coma. But the overall picture was what was so strange. Instead of a well-mixed dirty snowball, where all the different ices and dust are jumbled together, 3I Atlas seemed to be made of distinct layers, each with its own dominant chemical composition. It was like an onion. The very centre was releasing nickel without iron. A layer outside that was releasing cyanide, and the outermost layer was releasing carbon dioxide and carbon monoxide. This uneven chemical pattern is profoundly unusual. How could an object like this form? In the standard model of comet formation, a cloud of gas and dust slowly comes together, and all the different materials get mixed up. You don't expect to see this kind of clean separation, this chemical layering. It suggests that 3I Atlas formed in a very different and very specific kind of environment. Perhaps it formed in a place where the temperature and pressure changed very rapidly, causing different materials to freeze out in distinct layers. Or perhaps it is not a single object, but a collection of different pieces that have come together. Or maybe it has been processed in some way, with heat or radiation from its parent star altering its composition from the outside in. Whatever the cause, the layered secrets of 3I Atlas's chemistry are a major clue about its origin. Just like a geologist can read the history of the Earth in the layers of rock, astronomers were trying to read the history of a distant alien solar system in the chemical layers of this tiny visitor. The message they were reading was a strange one. It spoke of a place where the rules of chemistry were different, a place where nickel and iron go their separate ways, a place that could produce an object more like a layered cake than a dirty snowball. This strange chemical makeup was one of the strongest pieces of evidence that 3I Atlas was not just a visitor, but a true alien, born in a place in the galaxy that is fundamentally different from our home. Every clue about 3I Atlas, its extreme brightening, its mysterious push, its blue colour, its strange chemistry, all point to one overarching conclusion. This object did not form here. It is a product of a different environment, a different cosmic laboratory, with a different set of ingredients and conditions. The unique chemical signature and bizarre behaviour of 3I Atlas strongly suggest that it formed in a place in the universe that is vastly different from our own solar system. Its very existence prompts one of the most exciting questions in astronomy. Where did this object come from, and what is its home like? The primary evidence for its alien origin comes from its chemical composition. As we've seen, the chemical makeup of 3I Atlas is unlike that of any comet from our own solar system. The separation of nickel from iron, the distinct layers of different compounds, these are not features we see in the comets that were born in the same cloud of gas and dust as Earth and the other planets. Our comets are all variations on a theme. They have different amounts of certain ices and dust, but they are all drawn from the same basic pool of materials that was available when our solar system was young. They are all members of the same family. 3I Atlas is clearly not from this family. Its chemistry is so different that it might as well be from a different universe. By contrasting the makeup of 3I Atlas with the comets we know, we can start to guess what its home environment might have been like. For example, the high concentration of certain elements, like nickel, might suggest that it formed in the debris of a particular kind of stellar explosion, a supernova, which is known to create heavy elements. Or perhaps it formed in a protoplanetary disk, the spinning cloud of gas and dust around a young star that was much richer in certain metals than our own was. The layered structure might suggest it formed very close to its parent star, where it was baked in a specific way, with different layers of material being added or vaporized over time. This leads to fascinating speculation about the kind of star it might have come from. Was its parent star much bigger and hotter than our Sun? A star like that would have a very different kind of radiation and stellar wind, which could create very different chemical conditions in the disk around it. Or was it a much smaller, cooler star, a red dwarf? Or maybe it came from a binary star system, where two stars orbit each other, creating a complex and chaotic gravitational environment. The object itself is a messenger, a single data point from one of these other billions of star systems in our galaxy. By studying it, we're engaging in a form of interstellar archaeology, sifting through the remains of a world we can never visit to understand its history. The possibilities are endless. Perhaps it originated from a nebula, a giant cloud of gas and dust that was seeded with unusual elements from a nearby dying star. The specific chemical environment in that cloud could have led to the formation of icy bodies with this bizarre layered composition. When that nebula later formed a new star and planets, 3I Atlas could have been one of the leftover building blocks, and a chance gravitational encounter could have thrown it out of its home system and sent it on its long journey towards us. The study of 3I Atlas and other interstellar objects is therefore one of the only ways we can get direct physical evidence about the conditions in other solar systems. We can look at other stars with our telescopes, and we can even detect the planets around them, but we cannot tell from this distance what those planets are made of in detail. We cannot know the specific chemistry of their building blocks, but when one of those building blocks is delivered to our doorstep, we can study it up close. These objects are precious gifts from the galaxy. They are samples. They tell us whether our solar system is typical or unusual. They help us understand the full range of possibilities for how planetary systems can form and evolve. So while we may never know the exact star that 3I Atlas once called home, we can know that it was a place of different rules, a place where the cosmic recipe for making comets included ingredients or instructions that are missing from our own. It is a humbling reminder of the vastness and variety of the universe. We can sometimes fall into the trap of thinking that what we see around us is all there is. But objects like 3I Atlas tear down that notion. They show us that there are other ways for a solar system to be built, other paths for chemistry to take. It is a traveller from a distant land, and though it cannot speak, its very substance tells a story of a home far, far away, a home that, for now, we can only dream of. In any great mystery, there is often a piece of evidence that everyone wants to see, but which is frustratingly out of reach. In the story of 3I Atlas, that missing piece is a set of high-resolution images. As the object made its journey through the inner solar system, it was observed by dozens of telescopes, but one of them had a particularly good view. On October 2nd, as 3I Atlas was flying past the orbit of Mars, it was captured by the best camera in the neighbourhood, the Mars Reconnaissance Orbiter, or MRO. This NASA spacecraft has been orbiting Mars since 2006, and it carries an incredibly powerful camera called the High Resolution Imaging Science Experiment, or HiRISE. This camera is designed to take stunningly detailed pictures of the Martian surface. But on this day, it was pointed up at the strange visitor passing by. These images, captured by MRO, should be the best, clearest, most detailed pictures of 3I Atlas that exist. But there is a problem. NASA has not released them. This fact has become a source of controversy and speculation. Why would NASA, an agency whose mission is to explore and share its discoveries with the public, hold back the most important images of the most mysterious object to visit our solar system? The official reason given by the agency was related to a government funding shutdown. The agency stated that the shutdown caused a backlog and a delay in processing and releasing the data from its various missions. On the surface, this is a plausible explanation. Government shutdowns can and do disrupt the normal operations of agencies like NASA. Data from a spacecraft doesn't just appear on the internet. It has to be downloaded, processed, calibrated, and checked by teams of people. If those people are not at work, the data waits in a queue. However, for some observers, this explanation seems a little too convenient. The timing is what raises suspicion. The strangest object we've ever seen is flying by. The best camera in the solar system gets a look at it, and right at that moment, a bureaucratic issue prevents anyone from seeing the pictures. This has led to a theory that NASA might be deliberately hiding these images. The question is, why? What could be in those pictures that they would not want the public to see? This is where the speculation begins. The significance of these high-resolution images cannot be overstated. A clear picture could answer many of the key questions about 3i Atlas almost instantly. The biggest question is, what is its shape? All of our other observations are of a fuzzy point of light, surrounded by a cloud of gas and dust. We cannot see the solid object at the centre. Is it a lumpy potato-shaped rock like most comets and asteroids? Or is it something more unusual? The first interstellar object, Oumuamua, was thought to be very long and thin like a cigar or a pancake. Its shape was one of its biggest mysteries. A clear image of 3i Atlas would reveal its true form. Does it have a natural, irregular shape? Or does it have a more regular, structured shape that might suggest it is not a natural object? Beyond its shape, the images could reveal details about its surface. Is it a single, solid body? Or is it a loose collection of smaller rocks? A rubble pile held together by gravity? Is the surface smooth, or is it covered in craters and fissures? Can we see the jets of gas erupting from the surface? And if so, where are they coming from? All of this information would be invaluable for testing our theories. If we could see that the object is a single, solid rock that is not breaking apart, it would make the rapid mass loss theory hard to believe. If we could see that the gas jets are all coming from one side of the object, we could use that to explain the direction of the mysterious push. The MRO images hold the key to transforming 3i Atlas from a mysterious point of light into a real, physical object that we can see and understand. The fact that these crucial images are being withheld for whatever reason has only added fuel to the fire of speculation about this object. It creates an information vacuum, and in that vacuum, more dramatic theories can grow. The theory that NASA is hiding something is now a part of the story of 3i Atlas. It adds a layer of human drama and conspiracy to the cosmic mystery. Of course, the most likely explanation is still the official one, a simple, bureaucratic delay. The images may yet be released, and when they are, they may show nothing more than a blurry, lumpy rock. But until that happens, the mystery of the hidden images will remain. It is a reminder that the story of space exploration is not just about science and data. It is also about people, governments, and the choices they make about what to share with the world and when. For now, the best pictures of our mysterious visitor remain locked away, leaving us all to wonder what secrets they might hold. The most dramatic moments of 3i Atlas's journey through the inner solar system may be over, but its grand tour is far from finished. After its fiery close encounter with the Sun, the object is now on its way out. Its path is carrying it away from the centre of our solar system and back towards the cold, dark depths of interstellar space. But its exit is not a straight line. It will make a few more important stops along the way, giving scientists a few more chances to unravel its many secrets. The road ahead for 3i Atlas will take it past Jupiter, bring it close to Earth, and then, finally, send it on its way back into the galaxy. Currently, 3i Atlas is heading towards the orbit of Jupiter. This leg of the journey is important because it will take the object into a different region of space, further from the Sun's intense heat and radiation. As the object cools down, its activity should decrease. The massive outgassing that caused the brightness blast should subside. This quiet period will give astronomers an opportunity to study the solid object itself, the nucleus, with less interference from the bright cloud of gas and dust around it. They will be watching closely to see how quickly it fades. Does it return to its normal brightness as expected? Or does it continue to glow, or behave strangely even as it cools? This will be a key test of our models. The next major event on its schedule is its closest approach to Earth. This will be a critical moment for observation. Although the object will be further from the Sun, it will be closer to us, which means our telescopes will get their best look yet. Telescopes on the ground and in orbit, including the Hubble Space Telescope and the James Webb Space Telescope, will all be pointed at this tiny spot of light. This is when scientists hope to get definitive answers to some of the biggest questions. They will use their most powerful spectrometers to get the most detailed chemical analysis of its coma. They will try to directly measure the amount of gas and dust being released to test the outgassing theory, and they will get the best measurements of its size, shape, and rotation. This closest approach will be the climax of the scientific investigation, our last, best chance to study this visitor up close before it leaves us forever. After it passes Earth and Jupiter, the laws of gravity will take over for the final act. Jupiter is the largest planet in our solar system, and it's immense. Gravity will give 3i Atlas one final gravitational kick. This will slightly alter its path, but it will not be enough to capture it. The object is still moving too fast. It will continue on its hyperbolic path, a path that will carry it out of our solar system, never to return. Its journey from here on out will be a long and lonely one. It will cross the Kuiper Belt, the region of icy bodies beyond Neptune where many of our own comets come from. Then, it will pass through the Oort cloud, the vast spherical cloud of comets that surrounds our solar system at a great distance. Finally, after thousands of years, it will cross the boundary of our sun's gravitational influence and re-enter interstellar space. Its ultimate journey will take it back into the deep space between the stars. Its path will carry it through the constellations of Virgo and Leo as seen from Earth. It will become a silent traveller once more, a faint point of light moving through the void. It will carry with it the marks of its brief, violent journey through our solar system. Its surface will be changed by its close pass to our sun. And it will carry away with it a tiny, almost immeasurable change in its own momentum, a permanent record of the small non-gravitational push it experienced here. The story of 3i Atlas is a reminder that the universe is a dynamic, interconnected place. Objects are not confined to their own star systems. They can be ejected and sent on incredible journeys across the galaxy. We were fortunate enough to have our world-class observatories ready and waiting when this particular traveller happened to pass by. The data it has provided will be studied for years, even decades to come. Each new piece of information will help us to build a more complete picture of this object and the place it came from. The road ahead for 3i Atlas is a return to darkness and silence, but the light it shed during its brief time with us has illuminated our own understanding of the universe, and it has left us with a mystery that will inspire a new generation of scientists to look up at the sky and wonder what other visitors might be on their way. In the grand tapestry of the cosmos, we often look for patterns and connections. Sometimes, these connections are real and profound, revealing the deep laws of physics. Other times, they are simply coincidences, chance alignments that are fascinating to think about but have no deeper meaning. The final, strange footnote in the story of 3i Atlas is one of these fascinating coincidences. It connects our mysterious visitor to one of the greatest unsolved mysteries in the search for extraterrestrial intelligence. It is a connection not of physics, but of geography. 3i Atlas entered our solar system from the same direction in the sky, where we once heard a whisper from the stars. It came from the direction of the Sagittarius constellation. To understand the significance of this, we need to go back to the year 1977. At Ohio State University, there was a radio telescope nicknamed the Big Ear. Its job was to scan the skies, listening for any radio signals from space that might be a sign of an intelligent civilization. For years, it heard nothing but the random static of the cosmos, but on the night of August 15, 1977, the Big Ear detected something extraordinary. For a brief period of 72 seconds, it recorded a powerful, narrow-band radio signal. This signal was unlike any known natural phenomenon. It was strong and it was concentrated at a very specific frequency, just the kind of signal that some scientists had predicted an alien civilization might use to communicate. The astronomer who was reviewing the data, Jerry Eman, was so shocked by what he saw that he circled the signal on the computer printout and wrote one word next to it: "Wow." The signal has been known as the WOW signal ever since. The WOW signal is a legend in the history of science. It is the most compelling candidate for an extraterrestrial signal ever detected. But it has a crucial problem. It was never heard again. In the decades since, astronomers have repeatedly pointed their radio telescopes at that same patch of sky, listening for a repeat of the signal. They have heard nothing. It was a one-time event. A cosmic whisper that was heard for a moment and then was gone. The source of the WOW signal remains a complete mystery. Was it a signal from an alien civilization? Was it some unknown and rare natural phenomenon? Was it interference from a satellite or a terrestrial source that we have not been able to identify? No one knows. All we know is that it came from the direction of the constellation Sagittarius. And now, decades later, a physical object, the most mysterious object to ever enter our solar system, has arrived from that same direction. 3i Atlas traced a path back through space, and that path leads to Sagittarius. This connection is almost certainly a pure coincidence. The WOW signal was detected in 1977. 3i Atlas has been travelling for millions of years. The two events are separated by an immense amount of time, and the Sagittarius constellation is a large area of the sky. The fact that both came from the same general direction is likely just a chance alignment. The universe is a big place, and coincidences are bound to happen. But even if it is just a coincidence, it is a powerful and thought-provoking one. It ties together two of the great mysteries of our time. On the one hand, we have a potential message, a signal without an object. On the other, we have a potential object, 3i Atlas, a physical messenger that is behaving in ways we cannot explain. It is a poetic symmetry. The patch of sky that once gave us a mysterious sound has now given us a mysterious object. It is a reminder that this particular direction in the galaxy is, for us, a direction of mystery. Considering this connection is a way to engage with the sense of wonder that these events inspire, is it possible that the WOW signal was not a message, but some other kind of technological signal, perhaps from a probe or a ship that was passing by that star system long ago? Is it possible that the region of space from which 3i Atlas came is home to some unusual astronomical phenomena that could create both strange objects and strange radio signals? These are questions for science fiction, not for science, at least for now. But they are the kinds of questions that drive our curiosity. They push us to keep looking, to keep listening, and to keep wondering. The wow. Signal connection is the final strange piece of the puzzle of 3i Atlas. It is not a piece of hard evidence. It is a piece of cosmic poetry. It is a fun fact, a side note, a cosmic coincidence. But it serves to highlight the central theme of this entire story. The universe is a surprising and deeply mysterious place. We have learned a tremendous amount about the cosmos, but there are still things that happen that leave us speechless, things that make us, like Jerry Eman, want to write wow in the margins. 3i Atlas is one of those things. It is a visitor that has challenged our theories, sparked our imaginations, and reminded us that the next great discovery could come at any time from any direction. All we have to do is keep watching the skies. The mysteries of 3i Atlas are just beginning. What do you think it is? Share your theories in the comments and check out our exclusive 3i Atlas merch to support more deep dives.